with this right now, okay? So it says Schuyler runs north 15 degrees east. So the way you draw these is you're going to draw, and I hope you got this. I tried to type out as neatly as I could the solution. Like number one, I tried to type out as neatly as I could there for that. So what it says is draw a dotted line north. Going right like this. Perfect north. Okay, and then we're going to go 15 degrees, 15 degrees east. So what that means is you're starting north and you're rotating 15 degrees to the east, and that's going to be a 30. So that's a 1 and that's a 2. That's your starting and that's your middle point. Okay. Now, the nice thing about math is that the reason math teachers like navigation questions is everything's north, south, east, west. Why do math teachers like geography? Good. What is north, south, east, west? How do they intersect? Perpendicular. Good. They're all 90 degrees, okay? And we're going to take advantage of that in all these questions here, okay? Okay, so then how do I draw the second angle then? How do I draw the second one? Name, go ahead.
Do a little dotted line there.
Okay. Yeah. So I'm going to start at 2. This is the thing. Let's start at 2. I'll do it a different color. We're going to go west. And we're going to go 40 degrees north. Now that looks like it's straight north-south. It may not be. And there's 40 degrees. And that's going to connect sort of like this. And again, it's not straight north. Oh, goodness, that is the best triangle I've ever seen in my life. Okay, it's not straight north-south, so don't assume that it is. Okay, right? You can't necessarily say that. Are we okay on what the diagram is supposed to look like there? Because again, north going east, and then west going north. Okay, so if I'm solving, what am I going to solve this with eventually? Yeah.
Could you do sidelines like if you cross over to make it 90 degrees and subtract 90 from 15 and again?
Okay, good. So I like what you're saying here. Okay, first of all. So what I'm going to do, that's good. What I'm going to do on this blue triangle, this is a right angle right here. Okay. So what am I going to sum of the now? So what's that going to make that? This angle right here, this part right there. How much? 75. Okay. So again, that's good there. All together, I'm going to redraw this in a sec. Now, the thing is, I can't do anything with the rest of them, so I don't know how far left and right that red line is. So I can't just say, well, this is 15, well, it is, but that red line could be anywhere, so we can't really do that.
I know the 15, like you have 75 and 15.
Yeah.
But how did you do that? Where did you do
Yeah,
that?
good question. Okay, so, sorry, this is the thing when I'm not here, it's hard to explain. Remember, a triangle always has 180 degrees in it. So what we're saying is 75 and 15 is 90, and then another 90 is 180. That's right, like the right is 180. So I'm going to redraw this. You don't have to, but I'm going to. The triangle looks something like this now. Okay, so this is 115, but that's an X, that's a 30, and that's a 25. Can somebody tell me where I got 115 from? Or Brad, go ahead. 75 and 40, okay. The other angles we're not sure, because again, that X could be straight north-south. I don't think it is. Okay, but it's possible that it could be. Probably it's not, so you can't easily solve the other ones. How are we going to have to solve this then if I have two sides and an angle in between? What do I use? Cosine law. Okay. I love sine law. I don't know if I talked about this enough, how much I love sine law. Sine law is beautiful, Schuyler. You can do it in one step all as well. Okay, but why? Can somebody tell me, other than Liam, sorry, I'll stop you for a sec, why I can't use sine law here? Okay, this is like a real class. We have 15 kids and we got to actually call on people now. Yeah, Schuyler, go ahead. There's only one angle, okay, right? The thing is, you'd have to have something that's opposite. 25, you only be opposite here. 30, you only be opposite here. 115, you only have X, which is unknown, so it's not going to work. Yes?
Say the blue triangle in the first diagram was extended to the very end, but it was still 9 degrees. That 15 wouldn't be, it wouldn't be 15 degrees, but how to, like, more time. So if that blue dotted line went here, yes, that wouldn't be 15. Like if this whole thing, so how do we know that that's still 75?
Okay, so
the 75.
Yeah, because, the thing, okay, good question. The question was, how do you know this is 75? Because we don't know anything about where this works. Like I said, the red line isn't necessarily north-south, so how do you know that's 75? The thing that we do know for a fact is that north-south, east-west lines up. Okay, so because this line's north and that line's west, that has to be 90 degrees.
Okay.
And I'm saying this is north 15 degrees east. So compared to this line that's 15 degrees to that, so then this is 75 degrees compared to that line. Right? So you're comparing it to the big question, you're comparing it to like the north, south, east, west dotted lines, not to the lines of the triangle.
So you can't do that every time.
No. okay, because you don't know where this line is. Like, it looks like it's north south, but you're not. It could very much look like this right here. That's why I thought it was gonna be. Okay, can someone recite coastal law for me, please? In a loud, clear voice. Go ahead.
Square is B squared plus C squared, 2BC cos A.
Clear, that's okay. Okay, now, very good. Now for the tricky part. Someone other than Alex there. What is my, can somebody fill in the numbers here? Only one person remembers this from last year. Let's go back to Spidey here a second. Krista, go ahead. Good. So x squared is 25 squared, plus 30 squared, minus 2, 25, 30, close 150. Excuse me, remember that angles and sides are across from each other, so big A and small a are the same thing. Now, the nice thing with this, you can do this all in your calculator in one step. Okay? Cos of 115, could somebody tell me the number for cos of 115? So I just want to prove a point here for one step. You got it there? Right?
0.4.
Negative 0.46 something?
420.
426 something? Okay, we'll stick with that, okay? 25 squared, I think is 625, and that's 900, I think. Now, the point is you're saying, well, Ms. Sadler, that's good that you told me that. Why does that matter? Because that's a negative, you're actually adding this part at the end. Okay, two negatives going on there. Okay, so just be careful of that. The number should be bigger than 1525 when you square root it into two negatives. Okay. So everyone take a second, because I don't need to borrow a calculator. All nice. Okay. I'm just going to pause for a second confidentially. I don't want to insult anybody, so I'm just going to make a nice little bit of it. All right. So that's Liam 5 6. Perfect. Okay.
Yes.
Can somebody solve for x? I don't get an answer for that. Yeah, go ahead. Yes, final answer is fine.
70.
Oh, 70?
No, it'd be 46.46.
46.46? All right. Now, I'd like everyone just to make sure they get that same number. Is anyone unable to get 46.46? Take a second and actually calculate it out for me, please. Okay, because like again, you guys are the ones who have to do it. Now, Liam was trying to scare you when he walked in. He said, today we're doing 3D word problems, and no, we're not. That's the most challenging part of this. But yesterday's lesson was a fundamental part because we needed the north, south, east, west to understand. So I need to make sure that everyone in here understands at least what we did here. So when we try and crank it up to grade 11, that we'll be good in a few weeks. Probably next week we'll get that. Yes? No, you're good? All right, I'm going to pause the video and then we'll get started on today's lesson, which is called proofs.